All right, welcome once again to Chemistry Simplified. Today we'll be looking at redox reaction. They want us to define redox reaction. They want us to define oxidizing agent and reducing agent. They want us to look at how to balance redox equation and finally explain the rules for determining oxidation number. Okay, so in terms of oxygen now, the addition of oxygen is oxidation and the removal of oxygen is reduction. The addition of hydrogen is reduction, and the removal of hydrogen is oxidation. The addition of electropositive metal or element is the addition of electropositive elements now is reduction, okay, and the removal of electropositive element is oxidation, while the addition of electronegative element is oxidation and the removal of electronegative element is reduction. Okay, so in terms of increase in oxidation number, when you have an increase in the oxidation number, we say you have oxidation. But when the oxidation number decreases, you said you have reduction. What about our oxidizing agent and reducing agent? The compound or the element undergoing oxidation serves as the reducing agent, and the element or the compound undergoing reduction serves as the oxidizing agent. So in general, we are saying that our oxidizing agent, they are electron acceptor. We said that they are the substances that is reduced, and that's the substances in which the oxidation number decreases. Okay, and for our reducing agent, we say that they are the electron donor. Um, their oxidation number increases, and they are the substances that is oxidized in the process. All right. So examples of your oxidizing agent, you have your KMNO4, K2Cl2, O7, you have your MnO2, you have your oxygen. These are examples of oxidizing agent. While for our reducing agent, we have your ammonia, we have CO, we have H2S, we have SO2, we have iron, we have potassium iodide. These are examples of reducing agents. So how do we test for oxidizing agent in the laboratory? Okay, if you have a substance that is oxidizing agent in nature, if it reacts with iron 2, which is green in color, iron 2 changes to iron 3, that is brown in color. So from green to brown shows that what you've added is oxidizing agent, okay? Or if you're using hydrogen sulfide, you have a deposit of sulfur which is yellow in color. That shows that whatever you've added is an oxidizing agent. So what about reducing agent? Okay, so it changes the color of KMNO4 from purple to colorless. That shows that you have a reducing agent. And when it changes the color of your K2Cl2, that is your permanganate, from orange to green, what you have added is a reducing agent. Okay, so how do we balance a redox reaction? You can balance a redox reaction either using the alkaline medium or the acidic medium. So either ways, you are adding H plus or you're adding OH minus. You might have to add water to a part, or you might have to also balance the electron. But in all, the number of hydrogen must be balanced, all the elements must be balanced, including the number of electrons. So once this is done, you are good to go. And lastly, you want to look at the rules for determining the oxidation number. Now, don't forget that all elements in its free state have the oxidation number of 0. So your iron in its free state, oxidation number of 0, even your compound. Now, the oxidation number of simple ion is the ion that they carry. So let's say I have Cl minus. The oxidation number of Cl, that is chlorine, is -1. Okay, and the algebraic sum of oxidation number of all the elements in the compound is 0. As I said, all the algebraic sum of the element. Let's say if I have FeCl3 now, okay, the sum of all those elements is zero. All right. So thank you for the time. Do have a wonderful day. Bye.